Okay, so now we'll move on to the next type of proof in the center of math lesson. So far, we have discussed three major types of proofs, right? So we have discussed three major types by using calculus. So now we are going to move on to the next theory, the fourth. So I've just written the fourth one just to keep a number and to keep in check. Okay, so the next one that we are going to do, the proof, we are going to learn how to find the center of mass of a uniform lamina in the form of a sector of a circle. All right, guys. So I think you have already, this particular equation, you are already familiar with it, though you have not done the proof. In M2, you have already used this equation, the center of mass of a uniform lamina. So I think you should be familiar with this equation, right? 2r sine alpha over 3 alpha, where alpha is measured in radians. So I think you should recall it from M2, right? All right. So today what we are going to do, we are going to, in M3, you are going to learn how this equation is formed and what's the basis behind, creating this equation. All right. So this is how it works. So you have here, you can see when you're taking a sector of a circle, it's always possible to draw a line of symmetry. Am I correct? So always, in any sector of a circle, you can always draw a line of symmetry. Okay, so what you do here is we again do the same thing we did in M2. So if you recall, you mark the angles. I mean, when you mark the angle, you don't mark a single angle, right? What you do is you mark the angle, you mark two angles above the line of symmetry and below the line of symmetry, because the line of symmetry divides the angle exactly into two, right? So you don't mark a single angle. Instead, we mark two equal angles, right? So that's how we do it even in M2. So what we do here is the complete angle is 2 alpha. That's how we go here. Okay, so the complete angle is 2 alpha. So that means each side has an angle of alpha. All right, guys. So in calculus, the way we attempt this is we actually break this into strips, right? So we take our sector, okay, we take our sector and we attempt to break it into strips. That's what we do. All right. So guys, over here now you saw when we were breaking strips in the other questions, in the previous questions when we were breaking strips, you saw that we broke it. We took it vertically, right? So I told you that we take many strips. So we took it. I mean, most of the strips. I mean, we took it vertically, and there was one question where we even took the strips horizontally, right? So in another question, I think I showed you guys where we took the strips horizontally. You see, so according to the question. So always these strips must be taken in accordance to the question, right? You need to get the how do you say? You need to get the curve covered. Okay, so over here, how do you take the strips? Now, are you going to now this is the line of symmetry. So, are you going to break the strips in a vertical manner? Do you think this looks correct? Is it correct to take strips in a vertical manner? Because if you check here, guys, you can see from here to here, okay, you are taking the area under the line. But after that point, after this point onwards, I think you need to say the strips are now getting the curved part. So it's not uniform. Your strips need to be uniform, right? It needs to be under a single curve. It should not, now you can see the first part of the strips here. They are under the straight line. If you take vertical strips. And then the second part of the strips are going to be under the curve. So that's not going to work. Yeah. So in that case, the strips are not uniform. Because if it's uniform, it needs to every single strip has to represent the same person. So this is not representing the same person. So the one represents the line, the other one represents the curve. So that should not be what we go for. So that doesn't work, right, guys? So in this kind of a situation, the way we go for the strip is like this. Guys, can you see? So you can see the way we take strips is in this particular manner. Can you see? So we use the curved edge because obviously the sector. So we use the curved edge and we use that to actually create a sector. And now you can see what you're actually doing is you're not making strips with respect to the x-axis. We used to have delta x previously, right? So where the width between two strips was delta x. But now the width is going to be what? It's going to be the angle. Can you see delta theta? Okay, so you're dividing this angle into, you're taking this in and you're breaking this into so many strips. Do you see? So this is how, and this is going to be uniform because you're breaking it. You can see all of the strips are touching this. Okay, so you're going to break it in this manner. All right, guys, do you understand? So it's really important that you understand how this, how we break the strips. All right, guys. Okay, so now let's go into the theory part. So the theory part, you know what we do? We need to get the mass. Okay, the area of the strip will give the mass, and you have to calculate the center of mass. You have to do that for one strip. You need to get the mass and the center of mass of a single strip, and then you can use the M2 equation, right? So sigma M1 MIXI equals sigma MI into x bar. Okay, so this is the equation that we use. We have used it now so many times. So all you need to do to use this particular equation is get the area or get the mass of a single strip and get the center of mass of a single strip. Okay, so let's see how I got these values now, right?
Teacher,
All right, guys. So now let's go into the technical details, so the more intricate details. Okay, so let's see how we get the area and the center of mass. So first things first, you can see I first marked an angle theta here. Can you see? So like you did in the strips, when we draw the strip, you mark that place as x. Do you recall the place where you mark it? So over here, we are gonna mark our general angle because we are gonna work with angles now, right? Yeah, it's the angles that keeps dividing. So if this angle is delta theta, so what you do is you get the angle where you until the strip you mark this particular angle as theta. So theta is a general angle here, and delta theta is a very small variation in theta. Okay, so delta theta is just a small change in theta. Okay, and so theta over here, and then delta theta just to show that there's a small change in theta. All right, guys. So the thing is, when you're taking the area, I think you can see we've taken the area by taking the area of a sector. So that's quite easy, right? So you know in P1, area of a sector is half r square theta. You recall area of a sector is half r square theta when it's in radian mode. So half radius of the sector is r, and actually theta should be delta theta. You can see it's a very small change in the angle, right? It's a very small change in the angle, half r square delta theta. All right, guys. So that's the area of OPQ. And then to make it mass, you know what we do, right? To make it mass, we multiply by the rho, mass per unit area. Okay, so we multiply it by rho and we get the mass per unit area. All right, guys. So that's a really easy part. The little bit of a thinking part comes when it comes to the center of mass. Okay. So, guys, first things first. When you see this object, you can see there's a line of symmetry, right? The the sector has a line of symmetry, which means what? If the sector has a line of symmetry, you only need to find one coordinate because you know the line of symmetry will always have the center of mass is always going to be on the line of symmetry. So which means one center of mass coordinate is found. So for example, over here, since this x-axis is a line of symmetry, I think you guys can see because your G, the final center of mass is going to be at this point. I think you can see your y bar is going to be 0. Can you see? We don't need to find y bar, right? Y bar is already there. So we only need to find x bar. Only x bar needs to be found. So then we are only going to be concerned with the x coordinate. I'm not going to do sigma mi yi equal total mass into y bar. I don't need to do the y bar. Okay. I will only be doing the x bar because you can clearly see the final product, the center of mass y bar is 0. So we don't need to waste, we don't need to take any effort on that. Okay. So coming back to our strip, you know what we do? First thing we do is we get the mass of the strip. The next thing we do is we get the center of mass of the strip. So when it comes to the center of mass, guys, okay, so here we do the assumption. Okay, so you know when we did the previous strips also, the assumption was that when the strips are so tiny, it becomes rectangle, right? So we use the strip became a rectangle. Likewise, over here, when we say now, you know, this delta theta is really small. Now, I have taken this quite a large size here to show it to you, but it's in reality, we take it so small, so that this strip actually becomes what? This curved edge is actually being considered as a straight line because you take this angle to be really small, And when it's so small, the curved edge becomes a straight line. So that's the assumption we did in the previous part as well, right? The rectangles, the curved edge was taken as a straight line. So that's exactly what's happening here. When you take it, when delta theta is so small, okay, it's really small. This the curved edge becomes a straight line. So this is the enlarged version. Okay, so we need to draw enlarged versions to mark things, right? But this is in reality extremely small. So when it's extremely small, the curve part, you take it as a line. And then what you deal with is OPQ is a triangle. Can you see? You have the OPQ triangle. All right, guys. So when it comes to a triangle, you know how to find the center of mass by using the M2 technique. So how do you find the center of mass? So what we do here is we use the 2 to 1 method. Do you recall? So if you have a, I think you can see this is the OPQ is a isosceles triangle, right, guys? So, and you know these lengths, like the OP length is R, OQ length is also R. It's the radius, right? And so what you do here is, guys, so what we do here is we take even this length, now O to G, now I want to find the center of mass of this particular triangle, right? So this is the line of symmetry of that triangle. Can you guys see? So we take this length also, guys, you can see that what we do here is we take the OG, now the O to G length, you can see this 2 to 1 ratio. Do you recall this from M2? So what we do here is, guys, I hope you guys can see what's going on. So we take this full angle. So guys, the full angle here, I think you can see it's theta plus half of delta theta, right, guys? Can you see that? It's theta plus half of delta theta. Do you agree with me? The full angle here, like, you know, this angle. So this is actually theta plus half of delta theta. Do you agree with me? But you know, delta theta is so small. Do you agree? So we even did the same thing in the previous case. You remember when we took the x coordinate, it was x plus delta x over 2, and we told delta x is so small when you divide by 2, and when you add it to x, it's so small that you can neglect it. So it's the same story that happens here, right? So when you get this angle theta plus delta theta over 2, delta theta to over 2, delta theta is really small, divide by 2, it gets even smaller, and when you try to add it to theta, it does not make any significant impact. So then theta plus delta theta over 2 actually becomes what it is? It is theta, right, guys? So that we use that. I hope you guys can understand. We use that to actually get the x coordinate. So over here, this is my x-axis. Okay, over here, this is the x-axis. So I'm just drawing another diagram. All right. So what you need to do here is you guys can see here O to G is in the 2 to 1 ratio. So this is the theory you learn from M2. And guys, you can now I want this x value here, right? Because I want the x coordinate. So the length here is it's gonna be what? It's OG cos theta, because I told you that this angle theta plus delta theta over 2 is gonna be approximately theta. All right, guys. So I want the coordinate on the x-axis. I want the coordinate on the x-axis. So it's gonna be OG cos theta. Can you guys see? We don't need the y coordinate. Y coordinate is gonna be OG sin theta. So I don't need the y because we know the y bar already. Final answer. So we only need the x coordinate. So it's gonna be OG cos theta. Do you guys agree? And then guys, after getting OG cos theta, now the thing is, what about the OG length, right? What about the OG length? I think you guys can see that this length, the full length of this line, that's also R, right? Right, guys? This line is also R, right? Right, because if you consider this as a sector, you know that the full length here of this line is also R, isn't it? It's also approximately, it's also definitely directly equal to R, the line that goes in the middle of the sector, right? So then what you do is you can see, because OG is in the 2 to 1 ratio, you guys can see that OG length is 2/3, because you have 2 to 1 ratio. So it's going to be 2 parts out of total 3 parts, right? So 2/3 of this full length, the full length is R. All right, guys. So O to G length is 2/3 of this full length R. So that's why OG became 2/3 of R. 2/3 of R and cos theta, that gives you the distance along the x-axis. OG cos theta is the distance along the x-axis. All right, guys. So this is our math and this is our center of mass. That was the hardest part. And if you can get that, I think the rest of the part should be quite easy, because all you have to do is to use those values into this equation and actually perform the integration. All right, guys. So the most important thing here, the part you need to remember very specifically is what is the way we get the area, and also more specifically the center of mass is a little bit special here, right? The way we get it is a little bit tough, but that's the important thing. And if you can remember those two, then it's really easy to use it in this equation and perform the integration. All right, so let's put the values into the equation now. Okay, guys, so I hope this is clear to you. So once again, explaining why we didn't get the y coordinate. I'm not getting the y coordinate because it's not necessary, because I know the final y bar. The final answer for y bar is 0, so it's not necessary to get the y coordinate. Okay, we don't need to use this equation for y. All right, so now what you need to do here is let's apply to our equation. So we've used this equation so many times now. So when you're using proving center of mass using calculus, is one of the main equations we use. So this is the mass multiplied by center of mass of a single strip. The sigma tells you to take to consider all the strips. The sigma will add up all the strips, equals to sigma mi means the total mass, right? So total mass multiplied by x bar is the center of mass of the full shape. So guys, you can see what I've done here, right? So mass half r square delta theta into rho, you multiply by the center of mass 2 over 3 r cos theta equals the total mass. So actually over here, total mass, I actually don't need to use the integration here also if I want, because we can get the total mass. It's a sector, right? Half r square theta, and I could have used half r square 12 and gotten the answer in one go actually. Do you see? Okay, so total mass, or else another way is that you actually get the mass of a single strip and take the sigma. Okay, or else because it's a shape that we know. I think you recall me telling you this previously, right? So if it's a shape that you are already aware that you know the area, you can actually, for to sigma in mind, you can actually use the area. So the area is half r square. Theta is what? So the full shape has a theta of 2 alpha. And then that's the area. To make it mass, you have to multiply by a rho. So this becomes uh, r square alpha rho. So we could have used that anyway. So I have just gone with this. Okay. All right, guys. Okay, and then what's the next thing we do? We use as delta x. We need to make, in order to make this accurate. Okay, in order to make it accurate, you need to in order to make sure that we don't do any assumptions, because we have already taken this to be a straight line, right? So what we do here is that we say, in order to make this as accurate as possible, delta theta needs to be as small as possible. So as delta theta goes to 0, the summation becomes integral. So this is exactly what we've done before, and now we turn the summation to integral. Can you guys see? Okay, summation to integrals. By the way, what are our limits? So what are our limits? You can see that the integration, the delta theta becomes d theta, right? Okay. All right, guys. So okay, so we have the equation. So what are the limits now? So I was asking you the question, what are the limits we need to use? You can see here delta theta turns to d theta, right? So basically it's the theta limits that we need to use. So what are your theta limits, guys? Can you see? What are the theta limits we use? So you guys can see we are using the x-axis as the theta equals 0 line. Can you guys see? The x-axis is the theta equals 0 line, right? So you can see our integration happens, we are taking strips from down here, right guys? Can you see? We are taking strips from down here. Okay, so how does it go? You can see the lower strip here. So if you take the x line as theta 0, the lower line, it's going to be theta equal minus alpha, because alpha is the angle down here, and an equal angle up here. So the upper limit is going to be theta equal to the same positive value of that same alpha. Can you see? The lower limit minus alpha, upper limit plus alpha. Okay, so then let's substitute the values minus alpha to plus alpha, and you can see here, so those are your integration limits. Let's substitute that and get our x bar. All right, guys. So you can substitute those two values, take everything to one side. I hope this part is clear to you all, right? Because we have done several questions of the same type. I think it should be clear. So then you need to go for the integration. Integration happens with respect to theta, and these are our limits. So the rest of the part, I think it's quite simple. You can actually, try to do this on your own to get the answer. So take a few minutes to try it on your own as well. All right, guys. So you can see here I've cut off the half, and then the row also can be cut off, right? And you can take the r cube cos theta on top, then the r square comes down, and the integration limits minus alpha to plus alpha. And yeah, so and r is a constant, right? Integration happens with respect to theta, so r is a constant. You can take the r out of the integral sign, right? And then all you got to do is to integrate. So over here, the integration is not at all complex because you have a very simple integration here. Just to integrate cos theta in the denominator, in the numerator, and to integrate 1 in the denominator. Right, guys? So it's actually a very simple integration. Actually, this part of this proof is like really simple. And then cos integration is sine, and you apply the limits minus alpha to plus alpha. Integration of 1 is theta. Apply the limits again. So it's going to be sine alpha, then minus, and sine minus alpha, right? So you apply the two theta, the alpha values into theta, right, guys? Sine alpha minus sine minus alpha. The upper limit minus the lower limit. And at the bottom, it's alpha. Instead of theta, we substitute alpha, and then minus, and then you again put minus alpha theta. Can you guys see what I've done here? So then I end up getting here, guys, sine alpha. I think you know about this rule, right? So you should have heard of this rule probably. Yeah, in P3, right? In P3, P4, sine minus theta is equal to negative sine theta. So you should know this, right? Cos minus theta. In cos, the minus doesn't come out. And tan minus theta is minus tan. So these are some rules that you should know for acute angles, right? When theta is an acute angle, when theta is acute, okay, so when theta is acute, you have these rules, right? So sine minus theta is minus sine theta, cos minus theta is just cos theta, and tan minus theta is minus tan theta. So these are the things that you should already know these rules. So you apply that here, sine minus alpha, the minus comes out, and it becomes the minus minus becomes a plus sine alpha. All right, guys. So that's important. And then over here, sine alpha plus sine alpha is 2 sine alpha. In the bottom, you have alpha plus alpha 2 alpha. The 2 cuts out, and you have the equation that you are already familiar with, right? So you have learned this in N2 x bar is 2r sine alpha over 3 alpha, where alpha is in radian. All right, guys. So this is the proof. All right, guys. So let's quickly do a question under this. So exercise 5A, question number 8. Okay, so they say find by integration the center of mass of a uniform lamina in the shape of a quadrant of a circle of radius r as shown. So they say to find by integration. Now the thing is this, in the exam, okay, so most of the time if they want you to use directly the equation, either they'll tell you to directly use the equation. So over here they say find by integration, so which means find by integration means they expect you to actually do all the work where you need to get the strips, and you have to do all of those stuff. Do you recall? So basically you have to do all these parts again. That's what they are asking you to do in this question, where you get the area and where you get the center of mass. So you have to do all of that part. Okay, all of those stuff. Do you understand? That's what they require you to do. So I'll just do a really quick one of it. So because we know most of the stuff now, right? All right, guys. So over here, as you saw, the total mass, you can see that I have written all this stuff, the area, the mass. Okay, so these stuff, they don't change, right? The area is half r square delta theta, mass, you just multiply it by rho, center of mass is 2 over 3r cos theta. So it's the same thing that we did earlier. But the only difference right now is for the total mass, instead of going over the sigma mi, instead of taking the summation of each and every strip, I directly use the area of the sector because I know it's a sector with I can all directly use this equation, right? Half r square 2 alpha, guys. I use 2 alpha here. Okay, so each angle is alpha. I took each angle part as alpha, so I take the full angle as guys, can you see? Okay, so that means the complete angle is 2 alpha. All right, guys. So I get here r square alpha, and make sure you multiply by rho because area converts to mass when you multiply it with rho. All right, so that's the sigma mi. That's the major difference I did over here. So you can see I have actually used all these values into this equation. So you are familiar in using this now. So go through it slowly and you can see I've gotten the answer. And guys, what about the alpha value now, our limit? So you can clearly see since the angle is a 90, I think they have marked a 90 over here, right guys? You can't see it because I've drawn. So there is the alpha, the angle here is 90, which means your alpha is half of 90, isn't it? Because your alpha is going to be half of 90, 45. But if we are going to do this everything in radian, so alpha will be 5 over 4. So which means your lower limit is minus 5 over 4, upper limit is plus 5 over 4. Is that okay, guys? So minus 5 over 4 to plus 5 over 4. And you can see over here the alpha I have replaced with 5 over 4 because your alpha angle is 5 over 4. Okay, not 5 over 2 because we already used 2 alpha here. Okay, so 2 alpha would have been 5 over 2. But alpha is 5 over 4, right? So you use those values here and you can see I've used the limit. So it's exactly the same thing as before, but the only thing is we have actually used a specific angle now because they told us to use integration, and then you can get the center of mass x bar value 4 root 2 r over 3 pi. So you can go through my simplification. So to save time, I've just quickly done it, right? So this is the x bar. Y bar we don't need to find. We know y bar is 0 because the object is along the axis of symmetry. We already know that y bar is definitely 0. All right, guys. So this is because I've done the whole thing again because they asked us to do it by integration. Okay, so if they ask you to find the center of mass by integration, it means they require you to actually, perform all these tasks. Okay, so otherwise, if they ask you just find the center of mass with the and they tell you to, use the equation, you can directly use the equation. But over here, they're asking you to perform it by using integration. So this is how it's done. All right, guys. So I hope this part is clear to you.